Okay, good afternoon, all. I welcome you all for this today's session. Uh, so today's session will be based on non-destructive testing method. Already we have discussed the destructive testing methods. Okay, in our practical sessions, we have conducted the tensile testing method. Then we have discussed impact testing. In that IZOD and CHARPY impact test we have conducted in our lab, and hardness testing also we have discussed. Okay, these are some destructive testing methods. Now in today's session, we will discuss related to the non-destructive testing methods. Okay, so I will just take the review of a previous session, and I will start today's session. Okay, as far as this chapter is concerned, we have this syllabus for this chapter. In the destructive testing, already we have discussed this part, that tensile testing, hardness testing, and impact testing. We have completed these three testings, and only one session I will take on grip and fatigue testing. Okay, these two tests are remain that I will explain in the next session, probably on Monday. And in today's session, the non-destructive testing methods. Okay, it is in short, it is denoted by NDT, non-destructive testing methods, like dye penetrant test, magnetic particle test, then ultrasonic test, radiography test, ED current test, and one more type is there, that is simple visual inspection is there in this non-destructive testing method that we are going to discuss in today's session. Previously, we have conducted tensile testing, hardness testing, and impact testing in lab, and there we have discussed how this procedure. Okay, what is the procedure to conduct that test? Then how to prepare the specimen to conduct that test, and what is the outcome of that test. Okay, generally in destructive testing methods, so some questions will be there like this: what is the difference between destructive testing methods and non-destructive testing methods? Okay, so your answer will be like this: in destructive testing method, after conduction of that test, whichever specimen or test piece we have used, uh, its service life will get decreased, or its service life is affected, or sometimes it may get damaged. You cannot use it further. Okay, but in case of non-destructive testing, whichever workpiece we have used, we can use it in the actual service life also, because it is not damaged in this non-destructive testing method. Then another differentiating point will be like this: in destructive testing method, we are determining the properties of that material, like what is its tensile strength, what is the ductility of that material. Okay, different character, yield strength, what is its yield strength, then okay, modulus of elasticity, different parameters we can determine, means related to the properties. We will get the outcome in terms of its properties. Okay, in hardness also we are getting its resistance for that particular scratching or that particular load applied, whatever resistance it is providing. Then impact test, in all these tests we are getting information related to the properties. That is the some importance of this destructive testing method. And in non-destructive testing method, simply these are used for quality checking or inspection, for doing the inspection of the component. And we are using this non-destructive testing methods to determine whether any kind of defect or flaw is present in that component. It may be surface defect, or it may be internal defects, like there may be some cracks, some porosity may be there. Okay, like this, or any kind of inclusion is there, external particle may get added in that. So to determine any kind of flaws or defect present in that component, we are using non-destructive testing method. But for determining the properties, we are using destructive testing methods. Okay, so one by one we will start, or I will start it, and this is the prerequisites for this course. For better understanding, you should have some knowledge related to the engineering chemistry that you have studied in your first year, and maybe in this second year first sem. Then ferrous, non-ferrous materials and their alloys. Already we have discussed this part in metallurgy subject itself. Then manufacturing processes. Okay, this is the tensile testing. We have previously discussed this in previous practical sessions. Okay, this is this specimen preparation, how the specimen is created, gauge length, overall length. And then this is UTM, universal testing machine. We are this is the specimen, we are applying load, and this is the outcome of that load extension diagram. Okay, step by step, what is the effect of that load. And then depending on the material, we are getting different types of the stress strain curves. Okay, this is the stress strain curves for different kinds of materials. Okay, this is for ductile material without yield point. This is the curve for ductile material with yield point. Okay, and this is the stress strain curve for brittle material. And these are the properties. Okay, we are determining the properties. Stresses, different kinds of stresses are determined: elastic stress, proportional stress, breaking stress, yield stress. Then properties like toughness, ductility, malleability, resilience, all these properties can be determined depending on the output of this tensile testing only. Just you have to use different formulas here. Okay, then impact testing we have discussed, Charpy and ISOD impact test. Okay, in this, how the specimen preparation is done for Charpy test and ISOD test, we have discussed it, we have seen it. And how this test is conducted, its procedure we have discussed. Okay, different parameters in curves obtained. In fatigue test and creep test is there, that I will discuss, or we will discuss in the next session. I will discuss this part later. Now in today's session, we will try to complete this non-destructive testing method. Okay, so in non-destructive testing methods, in non-destructive testing method, already I have told you that this non-destructive testing method, in this method, at the end of this test, component is not damaged. Okay, or this method does not reduces the service life of the component. In destructive testing method, either component may get damaged, or its service life may get deteriorated or reduced. So this is the very big advantage of this process. Then here in this test, we are doesn't measuring here any mechanical properties like tensile strength, hardness, ductility, toughness. These properties are not measured here, or that properties are measured in destructive testing methods. Then why these non-destructive testing methods are conducted, or what is the use of this? These tests are used to detect or locate defect or flaws. Okay, any kind of defect, whether that defect is there in that component, it is detected, and its location is also detected here. Okay, its type and its location is detected in this non-destructive testing method. Why it is very important to detect this flaws or defects? Because if this flaw or defect gets carried out in the final component, and when you are using that component in the actual service life, then premature failure of that component may occur under different applications or different working conditions. Premature failure may be there due to presence of these defects. Hence, you should detect these defects and try to eliminate or try to avoid the use of such uh, component having the defects. This defect may be in the form of cracks, in the form of porosity. Okay, then now to do this non-destructive testing method, generally we are using 6 methods. Okay, that 6 methods I have highlighted in this slide. The first method is visual inspection. Okay, visual inspection is there. Okay, then magnetic particle inspection or magnetic particle testing. Then dye penetrant inspection, which is also termed as liquid penetrant testing. Already we have conducted one practical on this dye penetrant testing, but still I will repeat it. And then ED current inspection or ED current testing, then ultrasonic inspection, and radiography. So these 6 different non-destructive testing methods are there. Now, one by one, we are going to discuss this. We will start with this first one, visual inspection. Okay. Now, what is meaning of this visual inspection? Just we are doing this inspection with the help of our eyes. Okay. With the help of our naked eyes, we are doing this inspection, and some simple instruments we are using here. Okay. And what is the purpose? Whether any kind of surface defect is there. Okay, this visual inspection is used to detect or reveal any kind of surface defect. It may be in the form of cracks, but it should be visible. Here in this visual inspection, only visible defects which are visible with our naked eyes, that can be detected, and other parameters just we are checking in this visual inspection. Okay, it is this visual inspection is used to detect the surface defects. Then here we are examining the surface finish, whether surface finish is rough or is fine, and we are checking the component for its shape and size. Okay, this will be termed as the visual inspection. We are checking in whether any kind of visible surface defects are there. Then we are checking its surface finish, and we are examining the shape and size of the component, whether it is as per our requirement. That is visual inspection. And this visual inspection can be conducted with the help of some instruments. So for checking the dimensions of the component, okay, suppose I want to check its shape and size, then what I am going to do, simply I will check its dimensions. Now for checking the dimensions, we can go for different kinds of scales. Okay, different kinds of scales are there, different tapes or different micrometers are available, or different vernier caliper. Simply we can check with the help of different special gauges. Scales, tapes, micrometers or special gauges are used for checking the dimensions of the component. Okay, this will also considered as the visual inspection. Now the presence of surface cracks and the checking the quality of the surface finish, whether it is rough or it is fine, can be done by moving the fingers on the component. Okay, by moving the fingers on the component, if it is a rough surface, we can feel that with the help of our fingers, or if it is a fine, we can determine that also. And if any kind of crack is there on the surface, that also can be identified. And in some cases, okay, in some cases, for getting the better results, the we are using some magnifying glasses also, okay, to detect or to identify the surface defects or surface cracks. We are using some low power magnifying glasses to find out whether any kind of surface cracks are there or any kind of surface defects are there. So all these will be considered as a visual inspection. Is simply here what we are checking, whether any kind of surface defect is there, which is visible to our naked eyes, whether any, then we are checking the surface finish, and we are examining whether we have got that component in the required shape and size. To this, to perform this activity, to check the dimensions, we are using different instruments like different types of scales, tapes, or micrometers or different gauges are available that we are using here. Then roughness, surface quality check with the help of our fingers only. Then and to check the surface defects or cracks, sometimes we are going for use of magnifying glasses. So this is the visual inspection. Okay, this is the first type of non-destructive testing method. Then the second type here is the magnetic particle testing or magnetic particle inspection. Now in slide which is visible on your screen, here I have highlighted the working principle of the magnetic particle testing. Okay, if you have any doubt in the visual inspection, please let me know. Otherwise, I will start this magnetic particle testing or magnetic particle inspection. If any kind of doubt is there, please let me know via chat box. Okay. Okay. Now I will start with this magnetic particle inspection or magnetic particle testing. It has different types. But before going to discuss that different types, first we will try to understand the working principle of magnetic particle testing, how it works. Okay, now the this magnetic particle testing, the specimen under the examination, it is collected. This is your workpiece or specimen under the test, which is examined for whether any kind of defect is there or not. So what we are doing, first the magnetization of that specimen is done. Okay, magnetization is done. You can do it by passing the current. It may be direct current. You can go for direct current. It will be termed as direct magnetization, or you can go for alternating current also. Okay, depending on your requirement, you can go for direct magnetization or magnetization with the help of alternating current. Now, the actual principle here is the specimen under test. It is magnetized with the help by passing the current through that component, and in the next step, in the second step, what we are doing here, we are applying inspection medium. Ferromagnetic powder is there. Okay, fine ferromagnetic powder. We are applying it on the component. Okay, this is the second step. And what will happen if suppose any type of crack is there? Here you can see this is the crack, the spot where that particular crack or defect is there. What will happen there if crack is there? One pole will be formed at that crack area. Okay, and whichever fine ferromagnetic powder we have applied on the specimen, it will get concentrated towards that crack or that particular defect spot. Why it is happening? Because at that particular defect spot, pole is created. Okay, as we have known, we know that this n and s pole is there in the magnet, and it will attract the ferromagnetic material. Okay, now in the same way, suppose here crack is there, then one pole is created, and powder will get concentrated at that particular area, and in this way we will be able to find out where that defect is present on that particular specimen. Okay, now here we have two ways are there. Okay, means we can do the magnetization, and after completing that magnetization we can do the application of the inspection medium, that is fine ferromagnetic powder. Okay, separately we can do, or this operation can be performed simultaneously. Apply the current and means magnetize the specimen and apply the inspection medium. This can be done simultaneously or it can be done separately. Okay, so this is the principle of magnetic particle testing, and this magnetic particle testing is also known as magnaflux method. Okay, here it is shown how that powder particles are attracted. Okay, suppose here crack is there, then one pole is created, and that powder particles, fine ferromagnetic powder particle, will get attached or concentrated here at this particular spot. And this is the principle of magnetic particle testing. Now, this magnetic particle testing can be classified in different types, uh, and in different ways or on different basis. We can do the classification. The first way to do the classification of this magnetic particle testing is how we are using that inspection medium. Okay, here we are using the inspection medium used is fine ferromagnetic powder. Okay, suppose in the first method, that is termed as dry method, if we are magnetizing that component or specimen, and the fine ferromagnetic powder or inspection medium is applied, Simply we are applying that powder, okay, with the help of one vibrating screen or handshaker. We are applying that fine ferromagnetic powder on this specimen. Then it is a dry method, okay. And if suppose specimen is magnetized and the fine ferromagnetic powder is applied using the liquid medium like kerosene or petroleum, different kinds of petroleum oils. Okay, in that liquid medium, we are adding that fine ferromagnetic powder, and then we are applying that medium with the help of a spray or with the help of a brush, or we are directly dipping the component in the that particular liquid containing the fine ferromagnetic powder. Then it is termed as weight method. Okay, dry method of magnetic particle testing and weight method of the magnetic particle testing, depending on the medium used for application of the fine ferromagnetic powder. For application of the inspection medium, these two types are there: dry magnetic particle testing and weight magnetic particle testing. So these two types are there. And then another two types are there depending on the method of magnetization. Okay, this magnetic particle testing has two types depending on the method of magnetization. The first type, it is circular or crosswise magnetic particle testing, and the second is longitudinal method. Okay, here it is classified depending on the magnetization method. So here I have highlighted the how the magnetization is done. Okay, means depending on the direction of the electric current, we will get the magnetic field, and depending on that direction of the magnetic field, we will be able to detect the flaws or defects. Okay, all flaws cannot be detected in one condition. Okay, suppose this is the specimen, so this is the lengthwise defect or a crack. Okay, lengthwise or longitudinal crack. Then to detect this, circular magnetic field or crosswise magnetic field is required. Suppose transverse crack is there like this. This is the transverse crack. To detect this transverse crack, magnetic field be in lengthwise direction. Okay, means magnetic field should be perpendicular. Okay, or in that particular magnetization, if that crack is perpendicular to the direction of magnetic field, then and then only it is detected. Okay, if it is perpendicular to the magnetic field created in that particular specimen, then that crack is detected. Hence, for detecting the transverse crack, longitudinal magnetization is required, and for determination of the longitudinal or lengthwise cracks, circular magnetization is required. Okay, these are the conditions. Now, just I will explain it. To detect this lengthwise crack, so the direction of the current. Okay, here one concept I will highlight you. Please listen it carefully. The crack which is in the same direction of the electric current, it is detected, and the crack which is perpendicular to the direction of magnetic field, that cracks are detected. Okay, here to detect the lengthwise cracks, electric current direction should be same. Okay, electric current is passed through the length or lengthwise, and due to the lengthwise passing of this electric current, circular or crosswise magnetic field is created, and uh, after that, after doing this magnetization, fine ferromagnetic powder is applied on the surface, and after giving some time, if any kind of lengthwise crack or defect is there, all powder will get concentrated at that defect due to creation of magnetic poles. Okay, when electric current is lengthwise, then magnetic field, circular magnetic field is created, or circular magnetization happens, and lengthwise cracks are detected. So this is the first method of magnetization. In the second method, Okay, now we want to determine the transverse cracks. Then the direction of electric current should be parallel to it. Okay, in this way, in the circular direction, or with the help of one coil is wrapped around this specimen, and electric current is passed through that circular coil. Then the lengthwise magnetic field or longitudinal magnetic field is created. This is termed as longitudinal magnetization. And if any crack is there which is perpendicular to the direction of magnetic field, means this type of cracks, these are termed as transverse cracks. At that crack, whichever fine ferromagnetic powder we are applying on that surface, it will get concentrated at that defect area, and that particular crack is detected. Okay, in this way, two types of magnetic particle testings are there, depending on the method of magnetization. This longitudinal method of magnetization we are using for determining the transverse cracks, and circular or crosswise method of magnetization is used to determine the lengthwise cracks or longitudinal cracks. Okay, so here, this method, what are the advantages of this method? We are able to, or we can determine the surface cracks. Okay, only surface cracks or some subsurface cracks also be determined. Okay, for determining the subsurface cracks, we must go for direct magnetization instead of using the alternating current. We should go for use of direct current. Due to that direct magnetization only, we will be able to determine the subsurface cracks. Okay, as alternating current, its flow will be limited through the surfaces or through the layers. Its flow is limited. Hence, suppose up to 2-inch depth from this top layer or top portion of that specimen, up to 2-inch depth, we can determine that cracks also with the help of magnetic particle testing method. But we have to use the direct magnetization method. For the direct current must be applied. Okay, so this method can be used for ferrous materials only. Okay, different kinds of welded, casted, or forged components of different kinds of ferrous and its different alloys. For that only we can use this method. For non-ferrous alloys we cannot use this method. That is the limitation of this method. Non-ferrous alloys we cannot use it. Then one more limitation is there: internal defects cannot be detected by this method. Or we can determine whether there is any kind of internal defect, but exact location we cannot determine by this method. Okay, exact location of internal cracks cannot, it is not possible to determine with the help of this magnetic particle testing. Then demagnetization of the component is must. After completing this test, demagnetization, that is gradual removal of that magnetic field, or by decreasing the applied electric current, we are doing the demagnetization gradually. It is very necessary step, otherwise it may create some problem in the actual service life or actual practical use. Okay, so these are some advantages, disadvantages of this method, and applications also we have discussed. And so with this method, for different ferrous and its different alloys, we can determine the surface and subsurface cracks. Okay, whether it may be welded, casted, or forged components. For that, we can determine the surface and subsurface cracks with the help of this magnetic particle testing. Okay. Okay, there is one more method that is just for your information in this magnetic particle testing is magna glow method is there. Okay, same method. Okay, same method is there, but just what is the difference here? We are using some fluorescent magnetic uh, ferromagnetic powder. Okay, ferromagnetic powder means whenever it is observed under the ultraviolet rays, it emits lights. Okay, it emits lights. Means fine ferromagnetic powder is applied. Other magnetization method will be same. Application of the ferromagnetic powder will be same. Just its observation is done and under a dark room. Okay, in a dark room and with the help of UV rays. Okay, just we are changing that ferromagnetic powder. Fluorescent ferromagnetic powder is used, and when under we are doing the inspection, when ultraviolet rays falls on it, it emits the greenish and yellowish lights, so that its identification becomes very easily identified due to the different colored light. Greenish yellow colored light will be shown at that particular spot where defect is present. That will be termed as magna glow method. Okay, and for easy identification of cracks, okay, different uh, ferromagnetic powders are there in different colors. Okay, they are available in gray, gray, black, and red color. These three different colors are there, so that we can easily identify them. Okay, so this is the magnetic particle testing or magnetic particle inspection. This is the second type. Now I will move toward the third type, that is liquid penetrant testing or dye penetrant testing. If you have any query related to magnetic particle testing, please raise that query. I will try to resolve it. Otherwise, we will move toward this liquid penetrant testing or dye penetrant testing or inspection. If any query is there, please let me know. In magnetic particle inspection, okay, we have discussed here principle of magnetic particle testing, which is also known as magnaflux method. Then we have discussed two types. Okay, here two types of magnetization, that is circular and longitudinal magnetization. Then what is the dry method and what is the wet method? Then magna glow method of this magnetic particle testing that we have discussed. If any query is there, you can ask me. Otherwise, I will start this liquid penetrant inspection. Please let me know via chat box if any query is there. Sorry. Yes. Okay. Now, okay. If you are not having any queries, I will move towards this third type of non-destructive testing method, that is liquid penetrant inspection or liquid penetrant testing or dye penetrant testing. And already we have conducted one practical on this. Okay, in workshop we have conducted this practical. Okay, we have checked one welded component. Okay, one welded component we prepared one welding, and on that welded component we checked in that joint whether any kind of defect is there. Okay, now how this liquid penetrant inspection or liquid penetrant testing is done, some steps are there. This is the first step. Okay, first step here in first three pictures, this is the first stage, that is the cleaning. Okay, cleaning of that area or that component is done, where we are going to determine whether any kind of defect is present or not. And this cleaning is performed to make sure that it is free from grease, oil, or any kind of other external particles from the environment. And this cleaning is done with the help of cleaner. Okay, and it is generally indicated by the blue mark on that cleaner. Okay, chemical containing that cleaner, blue mark will be there. Okay, clean the surface with the abundant cleaner before the test. Okay, clean it, and after cleaning it, dry that specimen. Okay, first application of that cleaner is done, and you have to clean it from that surface is cleaned. Make sure that there should not be any oil, grease or any other dust particles, and after that it is dried. This is the first stage, that is the cleaning. Then in the second stage, application of penetrant is done. Okay, generally a red colored penetrant is used. This is the penetrant. It is applied on that surface. Penetrant is applied on the surface, and the extra penetrant applied on the surface, it is removed with the help of soft cotton. Okay, with the help of soft cotton, the extra penetrant applied on the surface is removed. Okay, this is the removal of excessive penetrant. Okay, this is the first method, cleaning of the surface. Second method, application of the penetrant. Second step, this is the third step, removal of excess penetrant from the surface with the help of soft cotton, soft and clean cotton. Okay, so this kind of surface will be obtained here. Now in the next stage, the fourth stage, application of developer is done. The generally it is indicated by a yellow mark on that chemical bottle. This is the developer. Okay, developer is applied on that surface. Okay, developer is applied, and if required, excessive developer is removed. Okay, here we can go for some powder particles also. Talc powder we can use, as we have used the chalk piece powder in our lab. Okay, we have done with both methods. Okay, powder also we have applied, chalk piece powder. Excess developer can be removed or give some time. Then what will happen after giving some time, after application of the developer? Okay, whichever that dye or red penetrant is there, that red penetrant will be pulled out from the area of defect. Okay, here defect is present in this particular area, it is pulled out from that defect, and that area will become red, and you can easily find out at that particular space defect is present. Okay, defect is present. So this, in this way, with the help of this cleaner, penetrant and developer, by following these stages, we can determine the cracks with the help of this dye penetrant or liquid penetrant inspection. Okay, now what is the advantage of this method? This method, we can use it for ferrous materials, we can use it for non-ferrous materials also, and we can use it on plastic material, ceramic material or glass materials. Okay, almost all types of materials, on all types of materials we can use it for determination of surface defects. Okay, only surface defects can be determined, surface or little subsurface defects. Okay, internal defects cannot be determined in this method. This is the disadvantage of this liquid penetrant inspection, that is internal defects cannot be determined in any kind of component, but surface and subsurface defects in all types of components, means it may be ferrous material, non-ferrous material or plastic material, ceramic material or glass material, we can able to find out surface and subsurface defect with the help of this liquid penetrant inspection method. Okay, just you have to follow these stages, you will be able to detect the defect if any defect is there. This is liquid penetrant inspection or dye penetrant inspection method. Now there is one more type is there in this liquid penetrant inspection, that is fluorescent penetrant inspection. Okay, fluorescent penetrant inspection. Now first let me know whether you have understood this liquid penetrant inspection, then I will move towards the fluorescent penetrant inspection method. Okay, that is not part of your syllabus, just for your information I'm explaining it. Okay, if you are not having any doubt in this liquid penetrant inspection method, there is one special type in this liquid penetrant or dye penetrant inspection. Sorry. That is fluorescent penetrant inspection. Now, how this fluorescent penetrant inspection is different? Just here, the dye. Okay, this penetrant is also termed as a dye. We are using a zyglo dye. Okay, zyglo name is there for that particular dye, and what is this zyglo dye? It contains the powder particles. Okay, it contains the powder particles which emits light when they some ultraviolet rays fall on it. Okay, when UV rays fall on that zyglo powder or zyglo dye, it emits light with different colors. Okay, so that identification becomes very easy. And when we are using that zyglo dye for this penetrant inspection, or it will be used as a penetrant. Okay, then that method will be termed as fluorescent penetrant inspection. Now, how it is conducted stepwise, some changes are there. Okay, initial stage, that is the cleaning method, it will remain same. Okay, with the help of the cleaner, surface is cleaned before the test and it is dried. Okay, this test is same. Then application of zyglo dye is done. Okay, application of zyglo dye is done, and if the excessive zyglo dye is applied on that surface, it is removed. Okay, it is removed with the help of water. Here we are using water instead of the soft cotton. We are using the water for removal of excessive zyglo dye. Okay, and after that the application of developer is done, and some time is we are giving some waiting time here. Then due to that, okay, after giving some developing time, what will happen? That developer will pull out that zyglo dye from the area where defect is present, and this specimen now we are observing it in a dark room, and we are allowing some UV rays to under the UV rays we are inspecting that component, and when that UV rays falls on that specimen, that area where that defect is there and that zyglo dye is accumulated, it will emit light. Okay, in this way we can detect the defect, and this method will be termed as fluorescent penetrant inspection method, where we are just using the zyglo dye as a penetrant. Okay, so this is the fluorescent penetrant inspection method. Okay, this way we have completed this three types. Visual inspection we have completed, magnetic particle testing also completed, then liquid penetrant inspection is completed, and we'll move towards the next type, that is ultrasonic inspection. Now, in this ultrasonic inspection, first we'll try to understand its working principle. Okay, here which working principle used here is, suppose there is one specimen or test specimen or sample is there, which we want to examine whether any kind of defect is there, or it is a defect free component. Then what we are doing, simply ultrasonic waves are allowed to pass through it. Okay, ultrasonic waves are allowed to pass through it. These ultrasonic waves will pass through that component in very rapid rate. Okay, if component is defect free, that ultrasonic waves will pass from one end up to the another end of that component, and on the other side we are collecting the output on the cathode ray oscilloscope screen, that is termed as CRO screen. And if in case of any kind of defect is there, that ultrasonic waves pattern also collected on the CRO screen, that is cathode ray oscilloscope screen. And for each passing of that ultrasonic waves, for each area or a region of that component, we are measuring the time also. Then depending on that time required for taken by that ultrasonic waves to reach from one end to the other end, and depending on the patterns obtained on the CRO screen, that is cathode ray oscilloscope screen, depending on that, we can determine any kind, if suppose any kind of defect is present in that component, or that component is defect free, depending on the pattern obtained. Okay, depending on in this way, the principle of this ultrasonic, this is the principle of ultrasonic inspection. Now this is very rapid way. Okay, this is very rapid way, and depend here ultrasonic inspection has a different types. It has generally two different types are there. The first is pulse echo method, and the second method is through transmission method. Okay, this is the transmission method. Okay, or it is also known as through transmission method, and this is the pulse echo method. Two types are there for this ultrasonic inspection method. Now, first I will explain it. This is the pulse echo method of ultrasonic inspection. Okay, this is the component under test. This is your test specimen. These are ultrasonic waves. Or here, this is the pulse echo method. These are pulse which we are allowing to pass through that component. Okay, with the help of one pulse generator, what we are doing here, with the help of one pulse generator, these pulse are generated, and with through one quartz crystal. This is one quartz crystal. Through this, these pulses are allowed to uh, pass through the component under test. Okay, and at the end, or here we are keeping one CRO screen, cathode ray oscilloscope screen, and we are collecting the pattern, and simultaneously we are measuring the time taken by that ultrasonic waves. Okay, for each wave. Okay, suppose this is the defect free component. Okay, this is the defect free component. It will pass and it will come at this quartz crystal. If defect is present in that component, then it will get reflected from that defect area only, back, reflected back from the defect, and wave which is reflected back from the other end of the material. Now these two patterns are collected for this wave. Okay, for this ultrasonic or this pulse, we will get this kind of pattern on this CRO screen. Okay, patterns obtained on the oscilloscope screen of this ultrasonic tester or testing method. Okay, here, okay, this kind of pattern will be obtained. This is the first wave for first wave. Okay, original pulse at the test surface, and this is the spot for waves reflected from the other surface. Okay, and time is calculated. Depending on the time required, we can determine the distance. Okay, and in the same way, if defect is there, please observe this. If defect is there, then we will end up with this kind of spot. Okay, this kind of spot we will get waves reflected from the defect. This is the wave reflected from the defect. Tiny spot will be there, and we can determine the distance depending on the speed of that ultrasonic wave and time required. Time, we can calculate the time also. Depending on that, we can determine its distance, means location can be determined, and from that spot or pattern obtained from that oscilloscope screen can determine its shape also. Means shape and size can be determined here with the help of that pulse echo method of ultrasonic inspection. Okay, this is the pulse echo method of ultrasonic inspection. If you have any doubt, let me know. Otherwise, I will continue to the next type. There any doubt is there? Please reply me. Okay, I will wait for a few minutes here. Please draw this diagram. Okay, this is the patterns obtained on the screen. Patterns, please draw this. I'll wait for a few minutes here. Is it done? If you have completed it, let me know. I will move towards the next type of this ultrasonic inspection. This is the first type only we have discussed, that is pulse echo method. Okay. Okay, I think you have completed. Thank you for your reply. We'll move towards the next type. This is the transmission method. It is also termed as through transmission method of ultrasonic inspection. Now, what we are doing here? Here we are using, this is your workpiece, okay, or workpiece or test specimen, and pulses are, this is two transducers we are using. This is one transducer at the one end of the specimen, and at the other end another transducer is there. This transducer will transmit these pulses through the component or test specimen, and another transducer which is present at the opposite end, it will collect the pulses which are already passed to the specimen, and its output is given. It will generate a signal on the CRO screen. Okay, so it will work like this. The pulses from this first transducer, it will transmit these pulses through the workpiece, and it is given to the other end. From that other end, the second transducer will collect it and give the signal on the CRO screen. If suppose these are the pulses, as this is the defective free area, if you check the output of this on the CRO screen, you will get a strong signal will be generated, and its a related time is also calculated by using some timer. And if any kind of defect is there, suppose here defect is present at this defect area, okay, this is pulses are passed, then due to this defect area, okay, here we are not received the pulses at the other end. Okay, due to this, whichever signal is generated at the CRO screen, it will be weak and disturbed signal. Okay, depending on that weak and disturbed signal, we can say that there when some flaw or defect is present, and with the help of respective time is calculated. Okay, time is again calculated, and depending on the CRO screen pattern or output and the time calculation, we can determine the location of that flaw. Okay, you can determine whether it is defect free depending on the CRO screen signals. If the signals are strong, then we can say that it is defect free. If disturbed and weak signals are obtained and defect is there, then depending on the time calculation, we can decide its location also. So this is the through transmission method of ultrasonic inspection. Okay, so this is the through transmission method. Now, this ultrasonic method can be used for detection of internal cracks. We can determine internal cracks, internal porosities. Okay, and we can use this method for metallic as well as non-metallic components. Okay, we can do this for metallic as well as non-metallic components. So this is these are the applications of the components. This ultrasonic inspection for metallic as well as non-metallic materials, we can determine the internal defects, and it is very rapid method also. So after this ultrasonic inspection, the next method is a radiography. If you have any doubt in the ultrasonic inspection, and its two types, that is pulse echo method and through transmission method, let me know. I will explain the Q reads. The next type is the radiography inspection. In this radiography, we are going to discuss the X-ray radiography and gamma ray radiography. If you have any doubt, let me know. Okay. If you are not having any defects, let's start the discussion related to the radiography. Now, in this radiography, this method is used for detecting the defects in the components which are manufactured by different methods like casting, forging, or welding. Okay, we can determine it. Now, here, how these defects are determined. Okay, suppose in one component we want to determine the defect. This is the component. Now, that particular component is exposed to radiations or okay radiations of short wavelengths. Okay, suppose this is the component and we want to detect whether any kind of defect is there, then it is exposed to the radiations of short wavelength. It may be X-ray or it may be gamma rays. Okay, now X-rays are obtained from the X-ray tube and gamma rays are obtained from different radioactive elements like radium, cobalt. Okay, generally we are using cobalt 60, and from that gamma rays are obtained. And depending on the use, suppose we are using X-rays, that particular radiography will be termed as X-ray radiography. And if we are using gamma rays for detecting the defects present in the component, then that radiography will be termed as gamma ray radiography. Okay, X-ray radiography, gamma ray radiography, then again neuron radiography is also there. Okay, depending on the use of different sources, different various types of radiographies are available. If we are using X-rays, it is X-ray radiography. Then if we are using the gamma rays, then it is gamma ray radiography. If neutrons are used, then it is neutron radiography. Okay, now here how actually we will able to find out the defects. Now suppose this is the component and in this component we want to find out the defect, then it is exposed to the radiations or waves of that particular different sources. Suppose X-rays or gamma rays we can use, then these are allowed to fall on that component and they will pass through that component. Okay, they will pass through that component. Now, the penetrating ability of these radiations, okay, penetrating ability of these radiations will depend on their wavelength, okay, and absorbing power of that material. Now, depending on the component, suppose these rays are passing through defect-free component, then at that defect-free component, their amount absorbed will be different. Okay, and the amount absorbed of that material will be different in the spot where defects are present. Then these radiations are allowed to pass through that component and they are collected on the film, whichever pattern is there, that is collected on the film, and that film is developed and we will get the different spots on that films. And if the defect is there, that defect can be identified as a darker region, because here the absorbing power of that material is different. As defect is there, absorbing power of that material is different, uh, and depending on that the film or some pattern will be developed. Okay, if for the X-ray it is we are using X-rays as a source, that film obtained will be termed as exograph. Okay, and if we are using the gamma rays, then that film obtained will be termed as a radiograph. Okay, depending on the rays used, different kinds of rays, depending on the rays used, these different types are there. Okay, I will explain it again, I will repeat this principle again. Okay, the in this radiography technique, here principle will be like this. Suppose this is the component, or this is the specimen in which we want to detect the flaws or defects. Then what we are doing here, here we are taking the or allowing some radiations of shorter wavelength to pass through that material. Okay, and generally these radiations of shorter wavelength are, we are using either X-rays or gamma rays. Gamma rays are obtained from different radioactive elements like the radium or cobalt 60. Then these X-rays are obtained from X-ray tubes or some radium capsules. We can obtain these X-rays, and these are allowed to pass through that material. Then the ability of that rays will be different to pass through that material depending on their wavelength. Shorter is the wavelength, then its passing ability will be more, penetrating ability will be more. And in this material, its materials absorbing capacity of that waves will be different. In any kind of the defect area, their absorbing capacity will be different, and defect free area absorbing capacity will be different. And at the end, with the help of one film, the whichever rays are passed through that component are collected and its pattern is obtained in the form of a one film. Suppose you have used the X-rays as the source, then whichever film is obtained, it is termed as exograph. And if suppose we used the gamma rays, then that film is termed as the radiograph. Okay, that film will be termed as radiographs. So this is the principle of radiography. And then different types are there: X-ray radiography, gamma ray radiography, then neuron radiography. Out of these two types we will discuss X-ray radiography and gamma ray radiography. So this is the X-ray radiography. This is the component here, and here we are collecting the film. Okay, cassette containing the film, where we are obtaining the results. Okay, initially here this setup we are using for generation of the X-rays. Okay, electrons from this cathode are allowed to fall on this anode, and the rays generated are termed as X-rays, and these are allowed to pass through this component under the inspection. This is the test specimen, and on the opposite side, the cassette is there. It will contain a film. On this pattern is collected. Okay, and a film is obtained. It will be termed as exograph. Okay, here arrangement is there. This is cathode, anode, X-rays are generated. This is the sample under the test specimen. To limit the scattering of this X-rays, this lead shield is used. A lead shield and a lead backing is used for protection or to avoid the scattering of these X-rays. It may be hazardous. Okay, it may be hazardous for the mankind or human beings. So avoid this scattering, this lead shield is used. This is the protective shield we are using here. Okay, these X-rays are obtained and allowed to fall on the test specimen, and its pattern is collected. This is the X-ray radiography. X-ray radiography. In X-ray radiography, at one time we can only inspect the one component only. At single time, only one component can be inspected. Now there is one new or developed radiography is X-ray radiography is there, that is termed as zero radiography. Yeah, this is one more term, that is zero radiography. What exactly happens in this zero radiography? In this zero radiography, here we are seeing this cassette film we are collecting. Here one dry plate is used. On that dry plate, we are obtaining the image, or that image is recorded, and it is done within um, 45 seconds or within a minute. Okay. One dry plate is there. In that dry plate, some coated aluminum powder is there. aluminum coated plate is there, and inside that some powder is there, and image is recorded in that plate within second time, 45 seconds to, sorry, within minutes time, 45 seconds to 60 seconds. Within that time the image is recorded or output of that um, radiography is obtained. This is a zero radiography. Zero radiography it is termed as. And if in normal X-ray radiography it almost takes 1 hour, but nowadays you can see that in the radiography within a few minutes they will give you the that particular radiography image, that is zero radiography. Okay, on the dry plate, the dry plates are there. uh, in X-rays, nowadays you can see in this medical field, if you observe the on that dry plate image is recorded within minute time. Okay, generally in our normal X-ray radiography it takes almost 1 hour to get the film, but in this zero radiography it within 45 seconds to 60 seconds you will get the output. Now in this X-ray radiography, some safety precautions you have to follow. Related two safety precautions or two precautions you have to take here to means all safety related precautions so that electric shocks and radiation injury can be avoided. Related to that, all precautions you have to take. Okay, then the next type of this radiography is gamma ray radiography. Almost same principle will be there, just the source will be different. Gamma ray radiations are used, and these are obtained from, generally we are using cobalt 60 here. And in this gamma ray radiography means gamma rays are produced from the source, and these are allowed to pass through the okay, I think now I'm audible. Okay, now what we are doing in this gamma ray radiography, the source is there which gives you the gamma rays. Generally cobalt 60 element radioactive element is used for obtaining these gamma rays. Then these gamma rays, these are the specimens, are allowed to pass through this specimen, and at the opposite side of that specimen one film will be there. Okay, to record the output film is there, and this film will be termed as a radiograph. Okay, output will be obtained here. This output will depend on the penetration capacity of this wavelengths generated from this radioactive element, and absorbing capacity of the material. Where defects are present, some darker spots will be there in that radiograph. Now what is the advantage of this? What is the advantage of this gamma ray radiography? At same time, we can perform this gamma ray radiography or gamma ray inspection on number of components. Okay, different casted, welded, or forged components can be inspected at the same time using this gamma ray radiography. Okay, in this radiography technique, we can determine internal defects. Okay, now this radiography we can use for different materials, different casted, welded, or forged joints. or components can be inspected for any kind of internal defect is present or not. Okay. Now, in the next point, we will try to compare this X-ray radiography and gamma ray radiography. Lots of times these questions may be asked here. That is the what are the differentiating points between X-ray radiography and gamma ray radiography. Okay, so the first point here you have to means first few points you have to explain it's related to the that X-ray, its wavelength and its penetration power. Now, X-rays have longer wavelength, a longer wavelength as compared to gamma rays. As its wavelength is longer, its penetration power is low as compared to gamma rays. As gamma rays have shorter wavelength and their penetration power is more. Then the scattering of that rays is more. Okay, we have observed that we are using that lead shield for the protection in the X-ray radiography. Why we are using it? Because scattering is more in the X-rays, but in gamma ray radiography or gamma rays, scattering will be very less. Now, large sized components and non-uniform components cannot be inspected in this X-ray radiography, but large sized components as well as non-uniform components can be easily inspected in this gamma ray radiography. And then this is the disadvantage of this X-ray radiography, that is a single component. X-ray technique can be used to examine only one component at any one time. Okay, but gamma ray techniques at a single time we can examine more than one component. A number of components can be examined for whether any kind of defect is there or it is defect free. Now, equipment which we are using in X-ray radiography, this equipment is large in size. It is not portable also, means it is less convenient. But in case of gamma ray radiography, equipment is small in size, then has better portability and more convenient. Okay, then X-ray technique, it is fast as compared to gamma rays. X-ray technique is very fast and it can be completed in a lesser time. Okay, zero radiography we have discussed within 45 seconds to 60 seconds it will be completed. Gamma ray technique, it is little bit slow and requires some few hours exposure or time. Now, X-ray technique, it will provide better results for component having thickness less than 50 mm, and gamma rays will provide better result if component size is more than 50 mm. Okay, thickness is more than 50 mm. Okay, these are some comparison points depending on some sources we are using. X-rays, then their penetration power, their wavelength, scattering, on which component we can use it, how many components we can inspect at the single time, then related to the equipment's portability, then speed of the testing, okay, and on which component it will be more effective. So these are some differentiating points between X-ray radiography and gamma ray radiography. Then we will move towards if you have any difficulty in this radiography, please let me know. Otherwise, we will move toward the last type of this non-destructive testing method, that is ED current testing. Please let me know if you have any difficulty. I will wait for few minutes here. Let me know any difficulties there. Please put that in the chat box. I will wait for few minutes. Okay, let me know whether any kind of query is there. Okay, whichever types we have discussed up till now, if any query is there, please ask me. Otherwise, I will move towards this last type of this destructive and non-destructive testing methods. Okay, this is non-destructive testing methods. Last type, that is ED current testing. Already we have discussed the five non-destructive testing methods. Okay, visual inspection, magnetic particle inspection, liquid penetrant inspection, ultrasonic testing, and radiography. We have discussed it. Now this is the ED current testing. Okay, now we will start this. This is ED current testing. So the principle of ED current testing is highlighted here. Okay, this is the material to be tested. Okay, this is material to be tested. Now, through this material to be tested, which material we want to test for defect. Now, what we are doing, ED currents are generated here. ED currents are generated and its magnetic impedance is checked by checking its output with the help of some coils. By checking its output in the form of voltage, we are checking, and depending on that impedance values, we are determining whether any kind of defect is there or not. And to create this ED current, we are using some coils. Through this coil, we are passing alternating current. Okay, this is coil. Through this coil, alternating current is passed or flown, and due to this flow of alternating currents through this coil, magnetic field is generated. Okay, this is coil's magnetic field shown by this purple color. Okay, red color is the coil through this alternating current is passed, and generally the frequency used of this alternating current is in the range of 200 hertz to 6 into 10 raised to 6 hertz. Okay, this frequency we can use. And the shape of the coil used in the CD current testing, we can use a flat coil or a cylindrical coil. Now, on which basis this frequency is selected? Okay, suppose we want to detect the surface and subsurface cracks, then high frequency alternating current is applied. Because when high frequency alternating current is used, then ED currents are only generated at the surface and subsurface area. Then if suppose we want to detect the deeper defects or cracks, then low frequency alternating current will be passed so that the ED current generated will flow through the some different surface layers, okay, for detecting the deeper defects. So depending on which defects you want to detect, we are choosing the frequency of alternating current. Then that alternating current is passed through this coil. Then due to this alternating current, the magnetic field is generated, and due to this magnetic field, ED currents are generated, and these ED currents, due to the skin effect, they will flow through the test piece. Okay, flow through the test piece, and the one depending on the voltage output, okay, different coils are used, and its magnetic impedance of that workpiece is checked. Magnetic impedance is checked, and depending on its variations in the value, we are checking the defects. Now here we are using two types of coils, absolute coil and differential coils. In absolute coil, okay, two types of test coils are there. Absolute coils, this only single coil is used, and directly its measurement is done here. In this absolute coils, the direct measurement is done, and in differential coils, okay, here with the help of absolute coil, with the help of single coil, we are directly measuring the inductance here. Okay, inductance or that impedance we are directly measuring. Means how much, what is the meaning of this impedance? How much resistance is provided for that flow of current? That value will be shown. Okay. Now in the differential coils, what we are using, two different coils we are using here. one coil is surrounded on the test standard specimen, and one coil will be surrounded on the sample specimen or test specimen. Okay, one standard specimen will be there, which is defect free, and one coil will be surrounded on that standard specimen, and one coil will be surrounded on the test specimen. And if output of these both coils is zero, okay, if output of these both coils is zero after application of this uh, alternating current, if output of that both coil is zero, then it is a defect free component. And if output is some providing some variations or some values, then there is some defect. Okay, one standard specimen and one test specimen is collected. Standard specimen is defect free. On that, one coil is surrounded, and on test specimen, one coil is surrounded. And these two coils output is checked. If it is zero, then that test specimen is free from defect. And if there is some variation in the inductance output, then some defects are there. So this is the difference between use of absolute coil eddy current testing method and differential coil eddy current testing method. This is the principle of this eddy current testing. Now the magnitude of eddy current. Okay, here we have seen these eddy currents are generated and they flow through the surface. Magnitude of these eddy currents depends on different parameters. Okay, this magnitude depends on magnitude and frequency of the alternating current flowing in the coil. Okay, already we have discussed this. ED current magnitude will depend on frequency of that magnitude and frequency of the alternating current flowing through the coil. Then electrical conductivity of the specimen. Okay, these are properties of the specimen. What is the electrical conductivity of the specimen? Then its magnetic permeability of that specimen, then shape of that specimen, then position of the coil and specimen. Okay, position, distance between this coil and the specimen, properties of this specimen used, microstructure and hardness of the specimen, and amount and type of the defects. Okay, depending on this, this induced ED current will be generated, and we are just checking the impedance, magnetic impedance. That is, you can say that impedance is nothing but the resistance provided to this ED current. Okay, here ED currents are generated and they are flowing through this material or this test specimen, and its impedance is measured, which indicates the resistance provided by this material through this flow of ED current. And depending on that resistance provided values, we can determine whether any defect is there. How we are detecting this? First, we have prepared one sample of standard specimen which is defect free, and by comparing with it, we are checking the other samples. Okay, so this is the ED current testing method, and these are the parameters which will affect the ED current magnitude. Okay, ED current magnitude depends on mainly it depends on the properties of the specimen and the alternating current used, frequency and magnitude of alternating current. Then properties of specimen like electrical conductivity, magnetic permeability, then its shape and size, then its microstructure and hardness, and type and amount of defect present in that specimen. And the important parameter is coil and specimen, relative position of that coil and specimen. Then the advantages and disadvantages of this ED current testing method will be like this. So this ED current testing method, it is a very rapid method and very fast method of detecting the flaws or defects. Then it does not require the direct electrical contact. Okay, here direct electrical contact is not required to the part in which we want to determine the defect. Then we can do the automation in this ED current testing method, so that we can do the inspection with rapid speed or high speed. These are advantages of this method. Okay, and what are the disadvantages? Disadvantages of this method is defects at the present, which are present exactly near to that center area of that specimen. cannot be detected, as eddy currents are not able to flow up to the center of that component. This is the disadvantage of eddy current testing. Defect which is present near to the center or exactly at that center is not possible to detect with the help of this eddy current testing, because the flow of eddy current is restricted, means it cannot penetrate up to the center of the specimen. Then what are the applications of this eddy current testing? Different applications are there. We can, these eddy current testing is suitable for detecting the, or to measure the coating thickness, then to sort dissimilar metals, okay, dissimilar metals, and detect the differences in their dissimilar metals, as the output will be different depending on the properties of that material. And then we can sort the dissimilar metals, and we can sort the materials based on their composition, microstructure, and other properties. Then with the help of this CD current testing, we can measure the properties of the material like electrical conductivity, magnetic permeability, grain size, whether any kind of heat treatment is done, or other physical dimensions can also be checked. And this method is suitable for testing the, this method is most suitable for testing ferrous as well as non-ferrous component for any kind of surface or subsurface defects. Okay, defects present at the surface, subsurface defects can be easily determined for ferrous as well as non-ferrous materials with the help of this ED current testing. Okay, so in this way, we have completed this non-destructive testing methods here. Okay, destructive testing methods, I have completed that in the practicals, hardness testing, tensile testing, impact testing, that I have completed. And in today's session, I have completed this non-destructive testing method. If you have any difficulty, let me know in a chat box. Otherwise, I will try to summarize this session. Okay, let me know in a chat box if any difficulty is there. Please put that in the chat box. Otherwise, I will stop this session. Okay, let me know any difficulties there. Balaji Pise, let me know whether any kind of difficulties there. Balaji Pise, are you there? No difficulty.
Not difficult.
Okay, thank you. Okay, if you are not having any difficulties, I will summarize this session, and simultaneously, while I am summarizing this session, you can put your attendance in the chat box. Okay. So in this today's session, we have discussed the different non-destructive testing method. First, we have started with the concept of what is non-destructive testing method, and here we discuss that in this non-destructive testing method, generally component is not damaged or its service life does not reduced, and this is generally used for checking the any kind of defects and detecting the location of that defect or flaws in the component. And here different 6 methods are used: visual inspection, magnetic particle inspection, penetrant inspection, then ED current inspection, ultrasonic inspection, and radiography. Then in visual inspection, here we are detecting the surface defects. Okay, surface defects. Then we are checking the quality of surface finish. and we are examining the shape and size of the component. And this visual inspection is done with the help of different scales, tapes, micrometers, special gauges, or examining the surface by moving the finger on that component surface. And different cracks, surface cracks are identified with low magnifying glasses. And in magnetic particle inspection, we are doing the magnetization of the test specimen, and by spreading or by applying the ferromagnetic powder as an inspection medium, we are detecting the defects. Now, this magnetic particle inspection or testing can be done in two ways: by dry method or wet method. It is also termed as magnaflux method. Then the nature of the defect, depending on the defect which can be detected, or the method of magnetization, two types are there. When circular magnetization is done, then we can determine lengthwise cracks, and this method is termed as circular magnetization method or crosswise method of magnetization. And when we want to determine the transverse crack, then longitudinal magnetic field is created, and this is termed as longitudinal method of magnetization. Then we have discussed its applications. Then Magnaglow method, we have discussed that. Then liquid penetrant inspection with the help of cleaner, then penetrant and developer. How this liquid penetrant inspection is done, we have discussed it. And also we have discussed the fluorescent penetrant inspection method, where we are using the zygo dye as a penetrant, okay, and which will emit the light under the UV rays. That's why it is termed as fluorescent penetrant inspection method. Then ultrasonic inspection we have discussed, and in this ultrasonic inspection we are using ultrasonic waves for detecting the flaws. With the help of CRO screen and time calculations, we are detecting the defects and its locations, and it is done by using pulse echo method and through transmission method. And we have discussed the nature of patterns obtained on the oscilloscope screen when there is no defect and when there is a defect. And then after this, we have discussed the principle of a radiography. And in this principle of a radiography, we have discussed the X-ray radiography and gamma ray radiography. Then we have discussed the concept of exographs, radiographs, and we have discussed zero radiography. Then different applications we have discussed. Then comparison of X-ray and gamma ray radiography, different points we have discussed here. And then ED current testing, principle of ED current testing, then how we are using the absolute coil and differential coils, what is the effect of alternating current on the detection of the cracks, and then what are the factors affecting the magnitude of ED current that we have discussed, and advantages, disadvantages, and applications of ED current testing we have discussed. So in this way, this is completed. Okay, so in this way, we have discussed different non-destructive testing methods related to their principle of working principle. Okay, we have discussed their working principle of each type, then their advantages, disadvantages, and different applications. Applications are very important, working principle and applications. So if you are not having any query, we can stop here. Thank you. Thank you for attending this session. Thank you. Thank you for attending this session.